shard your Lucene index. Okay, so can anyone tell me what is scaling? So there are like two types of scaling, right? So with Elasticsearch, you do something called the horizontal scaling. So can anyone tell me what horizontal scaling is? Uh, if you know the answer, just raise your hands. All right. Okay, so okay, just tell me how you would actually improve the performance of a server that you're having. Like, yeah, please. Okay, in application level, that would be right answer, but we are talking about databases, right? So Elasticsearch basically is a database. So how would you actually, scale something such as a database? You want to give mic to these people? Yeah. Yeah.
Having master and slave concepts.
Okay. Cool. All right.
Replicating
Replication.
yes.
Okay. Sharding. Yeah. Okay. So with Elasticsearch, you're okay. I'll tell you what vertical and scaling is. So let's just say that you're having a server with maybe 5 GB of RAM and a CPU, right? So and later on you notice that you're having like so many requests, right? And you want to make sure that your application still runs even if there are like multiple number of users accessing your website, right? So basically what you do is you can increase your CPU level, CPU power, or you can increase your RAM, and in turn you'll be having a bigger system, right? With more power. Does that make sense? Does that make sense? Yes. Okay, cool. So for Elasticsearch, we're basically what we're doing is we're not uh, having this approach. Instead, we'll be having something called the horizontal scale. Okay, basically what we do is we'll be having multiple servers rather than just having one single server, right? Okay, so that is basically what is shard. Okay, we'll get into what shard is in more detail in the upcoming slides. Okay, so basically what Elasticsearch does is that it's going to provide searching capabilities to your application, right? Okay, so it also does auto completion, it corrects typos, highlighting, it can handle synonyms and can also adjust relevance. Okay, important word is like relevance. Okay, just remember that. Okay, so does it actually remind you of something that you use in your everyday life? Hearing, correcting typos, highlighting matches, handling synonyms. Does it actually remind you guys of something that you use every day? Like Google, right? So basically what you can do is you can implement your own search engine using Elasticsearch, right? So before we actually talk deep into what Elasticsearch is, I want to uh, take a few minutes and talk about what the Elastic Stack is, right? So Elastic Stack comprises of different technologies like Logstash, XPack, Kibana, Beats, and Elasticsearch, right? So we'll just have like an overview of what these applications or tools are, right? Okay, Kibana. Okay, so Kibana is basically just a data visualization application. So just imagine that you're having a whole lot of data in your Elasticsearch database, right? And you use Kibana to make a dashboard, or create a dashboard so that you can have a visualization of what your data is, right? So it's actually used for that, and uh, that is perfectly one of the use cases of Elasticsearch as well, right? So you have your Elasticsearch and you have something called Kibana, and with that you can make your own dashboards. And you don't necessarily have to use Elasticsearch just for searching. This is an absolute famous use case as well. Okay, so this is how the dashboard looks. You can build your line graphs, pie charts, histograms, and all of that. So this is how the UI of Kibana looks like. Okay, Logstash is one of the next tool. Okay, so basically what it does is it can, gather logs from your applications and then can put it inside your Elasticsearch. That is how Logstash began, but later on it evolved into something more than just, getting logs and putting in Elasticsearch. So And XPack is a paid tool which does reporting, which can do monitoring, which can also do alerting. So let's just say that your application is having like running on 90% CPU, or it's running out of memory, right? So you want the users to actually know that your server is going to be down, right? So with the help of XPack, you can send an email to the owner telling them that your system is about to go down or something. So it's used for monitoring and alerting, etc. And Beats, it's something that is similar to Logstash. Uh, it can get metric data from your applications, uh, and then can ingest inside your Elasticsearch server. So it can also get incoming requests that comes into your web server, and then can put it inside your Elasticsearch. And with the help of Kibana, you can aggregate all those data and view it inside your dashboard. So these are like one of the popular use cases of Elasticsearch. Right now, we haven't talked about searching yet, but still, if you combine all of them together, you can still have a perfect use case. Okay, overall, Logstash and Beats, they're basically used for data ingestion, and so Elasticsearch is used for searching, analyzing, and storing data. And Kibana is used to visualize your data, and XPack is an add-on that provides like additional features. Okay, does it make sense? Any questions so far? So I would like this to be an interactive session, so you guys can, if you have any questions at all, just raise your hands. All right? You can stop me at any time. Okay, so how does Elasticsearch work? So now we'll dive deep into what Elasticsearch is all about, right? So data basically in Elasticsearch is actually stored as JSON objects. So unlike your traditional databases where you have rows and columns, in Elasticsearch you have them in as documents, and each document corresponds to a row in a traditional database. Okay, and like every JSON object, you have columns and fields and values as well, key values, right? And these fields correspond to like columns in a relational database. All right, so if you're taking 1000 feet view of what Elasticsearch is, then you'll see something like this. You have Elasticsearch providing you with wonderful APIs for searching, and you have a client. The client sends a request to these APIs, and you get a response back. Okay, the request would be a search query, right? So, and these are the popular products or companies that make use of Elasticsearch. Okay, so any questions so far? Nice. Okay, Elasticsearch architecture. Okay, so one of the things that you often hear when you talk about Elasticsearch is nodes and clusters. Okay, they are like center of Elasticsearch. So a node is typically just a server. So you can have like multiple servers, and if you group them all together, you have something called a cluster, right? The cluster is basically just a combination of different nodes, right? And indices and documents. All right, so we know what a document is now, right? A document is how data is actually stored in your Elasticsearch. And if you group multiple bunch of documents together, you can form something called an index. And an index uh, corresponds to a database in your relational databases, okay? Okay, so earlier we mentioned something about like horizontal scaling, right? So we'll just see how Elasticsearch does this, right? So let's just say that you're having a very big index, okay? So for database, I'm going to refer to as index, right? And the combination of all the documents together, they form something called the index. So you have a very big index, and you want, you don't actually want all of the data into a single database, but you want it to be in multiple databases, right? And these different shards could be present in like different nodes altogether. So let's just imagine that you're having like 100 documents in your index over here, and you can have like 33 documents in shard 1, 33 in shard 2, and 34 maybe in shard 3, right? Does it make sense? Yeah, please.
So how do you know when the request comes, right?
Yeah.
I mean, say
Mm.
the index range of say
Yeah. Yeah.
shard one
Mm-hmm.
go,
Mm-hmm.
maintains particular range. I mean, where does that mapping?
Okay. Yeah. So your question is, okay, when the request comes, how does Elasticsearch know which all shard that has to go through to get the relevant search results, right? So we'll get to that. So when we talk about the Elasticsearch architecture, so I'll be covering that topic. Don't worry. Okay. Okay. So and there are also concepts of what primary shards and replicas are. Okay, so this is like one of the ways by which Elasticsearch is able to maintain its resiliency, uh, making it a fault-tolerant database, right? So, uh, so in this example, we are having like 3 different nodes and 2 different shards. Okay, shard I'm going to be referring it as primary shard 0 and primary shard 1, and each of these shards would be having a duplicate copy of its own, and they will be present in like different servers, right? Different nodes. So as you can see, you're having primary shard 0 over here, and a copy of that is replica 0 is present in node 2 as well as is present in node 1. And likewise, uh, same for primary shard 1. So the essence is that even if like one of the nodes goes down, let's just say that 3 is completely down, you'll still be able to get all your data, right? With the help of node 1 and node 2. And even if node 1 goes, you still have node 2 to back you up with all your data. Okay, so now we talked about shards and replicas, right? So how do they get synchronized? A replica is basically a duplicate copy of your shard, right? So how do they actually get synchronized? Okay, let's just say that you're having, okay, so I'll just explain what this diagram is. So you're having like 2 different nodes, node A as well as node B, 2 different servers, right? And also node A is having shard A, and the copies of this shard is present in node B, right? You're having like 2 different replicas, right? And likewise for B, shard B is here, and replicas of shard B is present in node A, right? So when an update request comes in, right? Um, okay, so let's just assume that an update request comes to shard B over here. So the update process happens in shard B, and simultaneously in asynchronous manner, both the replicas of uh, shard B is updated. Okay. Okay, and once this update is completed, the user will be sent a response back, right? So that's how shards and replicas are synchronized together. Okay. Yeah. Not necessarily. It depends on how you configure your nodes and replicas.
Like the replica of shard B is
Okay. Yeah.
in node A, right?
Replica of shard B is a node A. Yes.
So if here there are only 2 nodes.
Yes.
Say if there are like 10 nodes,
Mm-hmm.
so there'll be like 10 replicas in each node, right?
It depends on how you actually configure it. Okay, you could have at least like one instead of having like 2 replicas over here, right? You could also have like 1 replica. It's based on how you actually configure your index,
Okay.
Elasticsearch index. Okay, yeah. Right. So depending upon that, Elasticsearch is automatically going to assign like shards and replicas to all the nodes together.
Okay. So
Okay.
like if this is how it is
Yes.
configured, then there'll be like 10 replicas in each node, right?
As in case if you're having like 10 different nodes,
Yeah.
yeah, you'll be having much number of replicas. So it is distributed in such a way that your Elasticsearch is resilient and it becomes fault tolerant, right? So it'll be automatically configured.
Okay. But the amount of computation will be more if there are like if it is configured in this.
Not really, because okay, so an update to shard B happens, simultaneously it be sent. Uh, the update request is sent across like all the different nodes at the same time in a synchronous manner
Yeah.
in a different node.
Yeah,
So it's
so
fine.
that will be like if we are scaling it in a large size,
Mm-hmm.
the amount of computation required would be more.
Computation would be in a different server, right? It'll be in a whole different server altogether.
So it has to be synced across different nodes.
Yes.
Like a more number of replicas will be there.
Yes, yes.
And so that's what I meant by computation.
A computation, but all of them is not inside a single server, right? So it does not actually affect. It doesn't make sense.
What I meant is like there'll be a lot of information sent between different nodes is what I meant as
Yeah.
computation.
Okay. So that's fine.
Okay.
So then it doesn't matter, right? Even if you're having like one node or two nodes or 10 nodes, still individual machine would be performing the similar task itself, right? Even if you're having like one or two nodes or 10 nodes, individual machine, their responsibility is going to be the same and their computation would be the same, right?
Okay. I just have another question. Like what is the application of Elastic? Where are the applications of the Elasticsearch?
Searching purposes, right? So let's just say that you're having an e-commerce website. Okay, so you want the results in such a way that the results are relevant to you, right? So let's just say that you search for let's just say a smartphone. You want like relevant results to come back. You want the phone that have like the highest rating to pop up first, right? So that's how it makes it relevant. So we'll talk about more on the applications, how we can actually work with Elasticsearch, right? Okay, cool. Okay, so in this example, we are having a cluster and we're having like three different nodes. All right. Oh, sorry.
Two replicas, right? You have two replicas, right? I mean, on the same node, right? I mean, if the node A goes down, I mean, both replica will anyway go down, right? I mean, within the same node, I mean, why do we replicate two copies in the same node?
You don't necessarily have to. Okay, so in this example, I just wanted to show you that this is how it actually works behind the scenes, right? So there's no point in actually having like two replicas inside the same node itself. Okay, so moving on. Okay, in this cluster, you're having like three different nodes again, and okay, the client is actually sending a search query and expecting a proper response back for his search query, right? So when the user is sending a search request, it could actually go to any one of the nodes to the cluster, inside the cluster, okay? Okay, so for example, if search query lands on the blue node that you see over here, then it's the responsibility of this blue node to send the message across the other nodes as well. So this becomes like an orchestrator node, okay? So, and every single node would be knowing what are all the data that the other nodes is having or the shard is having, okay? So basically this is what happens. So you search for something and the request is like forwarded to shard this node as well as this node, and then the results would be fetched back to this node, the blue node, and the results would be aggregated and then sent back to the client. Okay. Yeah.
Request to the other nodes.
Okay, so in case if it does not, right? So in this example, that's how it is looking like, but in case it's not, also you don't necessarily have to like read everything inside one node itself, right? So if this is working, and then if you can like pass a request to some other node, it'll be much more faster, right? Rather than having like a single computer doing all the work for you, right?
In this diagram, we are seeing a client is getting connected with shard B. Okay. So now the replicas is getting connected
the blue node.
Yeah, yes. Yeah. And the replicas will be getting connected with shard A and shard C. I mean node A and node C.
I'm sorry, can you repeat that? Or?
Client is getting connected with node B, and replicas are getting connected with, data is getting sent to node A and node B.
Okay, these two nodes over here, yes.
Yeah, yeah. So at the simultaneously, some other client is getting connected with node A. Then again the data will be given back to node B and node C. So this will continuously, it will be happening. In that case, like data usage will be more and speed will get reduced, right?
Not necessarily. So, okay, so internally it also has a load balancer where it can, orchestrate which one is also going to be the master node. So if, the blue node is actually having so many requests that it has to process to, then it will be forwarding that to a different node. Okay, does it make sense?
Means like I'm thinking like whether the speed will get reduced or what, like efficiency will get reduced, like.
So if it is actually forwarding the request to some other node and making
like,
it the orchestrating
like
node,
n number
then
of nodes we have, and n number of users will be connecting individual nodes. Then in that case, like data usage will be heavily loaded.
It depends. I mean, if you're having so the reason why we do it and the reason why we are having like horizontal scaling is so that, such a scenario does not happen. So if such a scenario happens, we just add one more server to it, right?
Okay.
Yeah.
One more question.
Yeah.
The reason behind why we are doing this one is like if in case node B is getting corrupted or something, so data will be fetched from node A or node C.
Yes, exactly.
So ideally this is the reason why we are doing this. So in this case, like node B is getting corrupted, is there any recovery mechanism behind this, or how it is?
Okay, so it depends on what sort of failure it is going through, right? It could be like a CPU destruction itself. So sometimes if you like restart your server, it'll be back up, right? So it depends on what sort of recovery it has to go through. Yeah, makes sense. Okay. Okay, so let's just imagine that you're.
So when the request comes, can you go to the previous slide? Sorry, excuse me. Yeah. So when the request comes to B, let's say it has to have served by A, right? I mean, I don't think it will be queried on the replica, right? Replica is only comes in if there is a failure, right?
No. So the advantage of having replica is that, the read request can actually happen in replicas as well.
Okay, so that was only in the write case.
Yes, write case.
Master.
Yeah. Yes. Only write case when you're having an update or something. That's when the replicas has to be synchronized as well.
So replicas itself can serve the clients directly.
Yeah. Yes.
Without going to the master or the.
Yes. Instead of going to the primary shard, replica can also serve the read as well.
Got it. Okay.
Okay. So. Okay, so let's just imagine that you're inserting a new document in your Elasticsearch database, okay? So it's actually called indexing a document. So when that happens, you have to know which shard it has to go to, right? So you're having like plenty of shards, and so it has to know which number of shard that has to go to. So basically what happens is that when you index a document, you'll have an ID. So if you're indexing an employee would be having an ID, right? So each document would be having a unique identifier. So if you don't provide it, Elasticsearch is automatically going to provide that for you. Okay, so as an algorithm, that kind of works something like this. So you have the shard number that you want would be equal to, you have some sort of a hash function that takes the ID and then will take the modulo of the number of shards that you have, right? So this would actually give us, so let's just say that you're having like 2 shards. So this will return an integer value, okay? And if you take a modulo, so you'll be getting values like 0, 1, and 2, 0 and 1, right? So it could be in any one of those, shard 1 or shard 0. This is how it computes which shard it is, right? Okay, so we'll talk about what analysis is, okay? Okay, so when you have your document and when it actually gets stored into Elasticsearch, it goes through a phase called analysis, right? Okay, so we'll just zoom into what analysis is. So basically, it comprises of something different filters, right? So if you're trying to index something, so let's just say that you're trying to store this text that you see over here, like 2 words. It's also having like HTML tags over here. So a character filter, there's a character filter in Elasticsearch that's called HTML strip. If you use that, then all the HTML content would be removed, right? And then it goes to something called a tokenizer, where the special characters will be broken down, and then you'll have like 2 different words altogether. So there are different types of tokenizers. like I mentioned, you have something called HTML strip. That's a character filter. And likewise, for tokenizer, you have a multiple number of them. And after tokenizer, it actually goes to something called a token filter. Basically, what happens is that it be converted into lowercase, and then it will be stored in the Elasticsearch database as something called an inverted index. Okay. So this is how an inverted index is an example that you can see over here. So let's just assume that you're having like 3 documents, document 1, 2, and 3, and okay. So basically, what happens is that you remember that you know, before storing it into the inverted index, it'll be tokenized. So which means, you know, all the words instead of having one complete sentence, it'll be broken down into like multiple words. Okay, and there's an analyzer called standard analyzer, which lower cases all these different tokens, and it'll be stored inside Elasticsearch inverted index. So this is what happens. Okay, so you're having like 3 documents. Assume that these are documents. So each word that you see over here would be listed down unique words, and you also have the number of frequency and which all documents contain these words. Say for example, is present in document 1, 2, and 3, right? So you have it in your inverted index, and inverted index is nothing but a data structure of Elasticsearch. So if the user is you know, searching for the word choice, document number 3 would be returned back to him. Okay.
So we talked about the document being the JSON object, right?
Yes.
So it's basically key value pair, right? So so this happens on keys and values, or both, or the whole document?
This actually happens in the values itself. So let's just say that you're having a field called name, right? The value of the name would be stored in the inverted index, and you can actually give whatever type of analyzer that you want for the field as well. Okay, so I'll talk more on that.
Thanks.
Don't worry. Okay, so now it's time for some hands-on. Okay, so what I'm going to be doing is I'm having I have Docker installed, and I'm taking the image of Elasticsearch. So you can find the image Elasticsearch website itself. So I'm just copying it and pasting it here. So this is basically going to open port number 9200. And also I'll be using Kibana. So other than just you know, Kibana being a data visualization tool, it also provides you with an additional functionality. It has something called the dev tools, from where you can type your own queries and see the results of that query. Okay. Okay, cool. Let's see if it is working. Okay, so we have something. Let's just see if it is. Okay, so we have Elasticsearch running in our server and port number 9200, and also we'll just install Kibana as well. So basically what we're going to do is we will be using Elasticsearch, and we'll be indexing a few documents, and we'll be writing some queries, and how we'll see how we can actually get the relevant documents from your search query. Okay, so these commands that you see over here can be found from their official website. Okay, so this is the UI wherein you would write your Elasticsearch queries, right? So this is the command that you would use for inserting a new index. So this is basically just a HTTP endpoint that you're calling. So basically Elasticsearch provides these APIs, and with this you'll be able to create your index. And okay, and these are some of the commands that you see. So as of here, you can see that some commands like took one. So basically, it means that it took 1 millisecond to fetch the result, and these things that you see over here, so timed out. So it basically says that while querying this request, whether or not it was timed out. Okay, so I'll just put in some data into Elasticsearch now. Okay, so. I'll have the command somewhere over here. So this is an endpoint that is actually used for entering bulk data into Elasticsearch. So I'm having a JSON file inside my downloads folder. It's called products.json. So I'll be just inserting them, and you can see that it's having like 1,000 documents. And now if I just check search match all, you'll see all the 1,000 records, right? Okay, so I'll just talk about what makes Elasticsearch so unique and so powerful. Okay, so I added these documents, right? So there's something called dynamic mapping. So so when I added a document with the data that each field is having, it's automatically going to assign the type for each field. So you can explicitly mention that, otherwise Elasticsearch is going to take the default mapping types. Okay, and these are basically the different mapping types that you have. So as I mentioned, you remember I mentioned something about analyzers, right? So you have a document, the content of the document will be goes through an analyzer, and then it will be stored in the inverted index. And you'll have like different tokens, and they'll be all in lowercase if you're using some certain analyzer, right? So there is something called analyzed fields, and as well as something that is not analyzed. So any field, so let's just say that you're having a field called name, right? And you can make it analyzed, okay? And if you do that, whatever content that you have inside the name field will be stored as tokens inside Elasticsearch, right? So the data type that you must give is called text. Otherwise, you can use something called keyword. Okay, so if you don't want your field to be analyzed, then you give it the type keyword. And you have your date, boolean, binary, object, data type, etc. Okay. So, okay, let's just see what actually happens when you analyze a field, right? So let's just see how Elasticsearch is going to break them down into tokens and store them in your inverted index. So I'm just going to get it from Slice API. Okay, so as I mentioned before, we're having different types of analyzers, and the one that we're using right here is something called the standard analyzer. And the standard analyzer uses a standard tokenizer. Okay, so you can read more about these in the documentations. It's very, very good. Okay, so let's just see what happens. So you can see that it is split with the white space in between, and they're all in lower cases, and they're all in different tokens, and this is how Elasticsearch, inside Elasticsearch, it is stored. Okay, now we'll move on to the searching part. Okay, so even while searching, you have something called term query and match query. Okay, so as I mentioned before, if you're want your results to be analyzed, right? So you'll be using something called match query. Otherwise, you'll use term query. I'll just show an example so that will make more sense. So basically, this is a syntax on how you actually do your searches in Elasticsearch. So you have something called query context, and you have something called match. So let's just see the results in. Okay. Better? Okay. Okay, so let's just see what all documents that you have in your Elasticsearch right now. Okay, so so I'll just search for okay, name onions, right? Right. So if we do this, what do you think you'd get? So it'll actually give you results that have the name as onions in it, right? So you get there's also you have something called the term query that I mentioned before, right? So I'll just copy the entire. Okay, let's just see what we get. Okay, so for this match query, you actually got these results, and for term query, you did not. Okay, so anyone can give me a guess as to why you did not get the result? Okay, so you're basically having two different types of queries. One is analyzed and the other one is not analyzed, right? So if it is, okay, so let's just say that you're using term query and you're searching for coffee. So in our example, we used onions instead of you're searching coffee, right? With a lowercase, that would be found inside the Elasticsearch inverted index because it's in lowercase and you're searching for that, right? So you'll get a document. But if it is like an uppercase, you will not, because a term query is not analyzed. So it does not go through the process of tokenizing and then lowercasing and storing it into the inverted index, right? But in case of a match query, it goes through the analysis process, right? So the analysis process that we mentioned before, right? So whatever the case is over here, it will be tokenized and it'll be filtered and it'll be converted into lowercase and stored inside the inverted index, right? Okay. So we have different types of query types. So it could be something as simple as, searching for a word like food equal to burger. That's a basic simple query. And with Elasticsearch, you can also build very complex queries as well, right? So you can have something called a leaf query, which is a simple query. And then you can put it inside a Boolean operator. And then you can make it a compound query, and you can have like more compound queries inside.
So in your example, you're showing the products with names and description, right?
Yes.
So you are searching mostly using the name, I mean, being the keyword, and you have the values, right? But let's say if I query something on the description,
Yes.
like one of the text within the description, will it be the same time does it take, or how does the query response in the description?
Okay, so even in the description, as you can see here, it doesn't actually matter what the field is, right? So every single word that you see over here, right? So if it's a description and if it is having an analyzer, then every single word would be tokenized and would be put inside your inverted index, right? So, and if you're searching for, let's say you're searching for justo, right? So it will be looking into the inverted index. It does not matter which document it is. So it will be looking into the inverted index and it will be fetching that document. Okay, so that's why it's called inverted index, right? So basically, every single word is indexed here, right? Does that answer your question?
Yeah, I was thinking more about the query response, because since description, if it's stored as a data object instead of the, let's say in the name being a string or just a character, right? Like, depends on the data type. If the description is a data object, then is it, but it seems like you're saying everything is including, doesn't matter what type of data it is.
Yeah, if it is a string, it does not actually, the length of this description does not actually matter, because every single word that you see will be tokenized, right? Yeah. And then the associate document is also there in the inverted index. Yeah. So basically, it's just like saying that, you're having like primary indexes in all the different words inside description, right? Like an index over there. So, so it doesn't matter. Okay, so now what we're going to do is we're going to see how we can actually search and add some relevance to our search. Okay, so also we'll talk about building a complex or compound query as well. Okay, so you actually use something called the bool operator for this. Yeah. So for this, I actually have a different data set, so I'll just use that instead. Recipes. Right. Okay. If you refresh and if you check, you'll have your recipes index as well. So Kibana provides you with amazing intelligence so that you can write your query even faster. So it has like 21 documents, and this is how the document is structured. So you have servings, you have steps, and you have something called ingredients, right? So let's just say that you want recipes that has salt in it, and you don't want lemon juice in it. Okay, so how would you actually form a query like that, right? So let's just see. So this is an API that Elasticsearch provides. It's a search API. So we'll create complex compound queries using bool. So okay, so there are types of queries, like you have a must clause, and you have something called must not, and you also have something called should. Okay, so am I making sense? Okay, so it's easy. So basically, when you have something called must inside a Boolean query, it's just saying that it has to be there, right? Okay. So what is it? Our field name should match. What was the field? It was yes, good. Ingredients name salt, right? So okay, so now it's going to give us all the ingredients that have salt in it. Okay, so let's just say that we don't want beans inside our search, right? So we can use something called must not. Okay, just copy this thing right here, paste it here. What was it? Yes. So as of right now, we're having how many documents? Okay, we're having 20 documents. So maybe 2 of the documents had beans in it. So okay, so that's how you actually query it. You can have multiple must queries. So if you want so and so things that you actually need to have, then you can mention that inside the must, and those things that you don't want, you can mention it inside must not. And okay, so there is something else which is called should. Basically what it actually does is that it's going to provide more relevance to your search. Okay, so let's just say that you're inside an e-commerce application and you're searching for washing machines. Okay, and let's just say that you're looking for semi-automatic, right? But even if okay, so you prefer semi-automatic. You just give your preference as semi-automatic. So basically what you want is you want the semi-automatic washing machines to come on the top, right? So but it does not matter whether fully automatic comes as well, right? So basically you're adding a relevance to the semi-automatic washing machine so that it will appear first. Also, one thing that I forgot to mention is that you can see that every single document. So this array that you see over here is a hits that will show you the number of documents it has received, right? And every single document would be having a score associated with it. Okay, so it is something that is calculated internally, and it is actually retrieved in the descending order, right? So the document that has the most score will be shown first. Okay, so what I'm trying to do is I'm going to say that, okay, I want pepper. Let's just say that I'm having some preference for pepper, but even if pepper is not there, it's still fine. But if it is, I want this to be on the top. So match. Right. So this ID of this is ID 9. Document ID is 9. So let's just see what happens. It's not basically going to affect the filtering of the search, but just adds the relevance, and you can see that this actually comes at top. So that's one of the ways by which you can increase the relevance in your search. Any questions on this?
specifically checking for ingredients.day. Can I give search everywhere?
Okay, you want to search like multiple fields.
Correct. Yes.
Okay, yeah, there is something called multi-fields wherein you can do it. So you can specify like multiple fields, and then you can get the results. So instead of checking for this particular field name, you can check it inside steps or title or description. Yeah. This one.
In the Kibana one, the analyzer, right? Where you were showing something.
Inside Kibana or inside the slides?
Query. So what is that on the right side? That's the document, right?
Yeah, this is the result of the search.
No, the right side. The right side is a result, or that's the document?
This that you see over here, right?
Yeah.
Yeah, that will be the document, which will be the result. So if you're searching for something, that particular word which all documents match, they'll be coming as a result.
Okay, all the documents will be coming as a result. But what are those lines inside? They are the document, or like the content of the document, or like
these things that you see over here,
yeah,
right? Yes,
yeah.
those are okay. I'll just show you what the JSON looks like. So, so I'll just open. So basically, this is how it looks like. So these are just JSON objects, and you're just giving IDs and also the object, and you're using the bulk insert query. So these JSON objects would be inserted inside Elasticsearch, and that entire document, the JSON object is listed back.
So the one, so here you have a lot. So for that query, this is the result, is what you're saying?
Yes, whatever.
Based on all the documents that are present in the database.
Exactly.
Okay. Thank you.
Yes, that's also possible. You can Elasticsearch provides regular expression searching as well. So you can actually go through this documentation, and you can find like not just I'm just barely scratching the surface of what Elasticsearch is. There's a whole lot of things that you can actually do with Elasticsearch, right? So yes. Yes. Okay. In fact, I'll just show you that. So you're asking whether you okay, say that you want the preparation time. I think that's a field over here. Oh, okay. So you want documents that have, okay, so that's something that could be added as a relevance, right? So you would prefer that you want your dish to be served or made within like 15 minutes, but even if it takes 20 minutes, it's still fine for you, right? So you can maybe put that inside should, so that the number of documents would not affect, but the relevance is also added. So and you can say preparation time. Greater than, it should be less than 40 minutes, right? so if we do this, then added relevancy. So those recipes that require less than 40 minutes would be shown at the top, right? So okay, so let's just say that you're having a match query, right? Um, Okay, before that, I just wanted to say that, I mentioned something about keyword data type as well, right? So which is something that is not analyzed, right? So what does it actually mean that when you say it is not analyzed? Yeah, it is not stored into the inverted index, so it won't be lowercase and it won't be tokenized, right? So so you can imagine that if I were to type let's just see what we get. Just say easy, probably will not get anything because keyword type is not um, analyzed. So basically, where do you actually use keyword? So if you want to do like a exact match of something, right? Even let's just say for instance like email address. So for that, maybe you can use the keyword. Sorry. So we'll just see how Elasticsearch internally breaks down a match query, right? Okay, so let's just say that I'm typing this easy pasta. Okay, so this would be translated as a bool query. We convert it into two different must blocks. So right, so there is something that you can notice over here. So it says that the maximum score, so which means the document that is having the maximum score will be mentioned over here. So if you can see that if I'm querying by this as well as I'm querying by this, it'll give you the same result, right? Okay, so one of the things that you can actually do is, each time you get a relevant document, right? You can also have the number of times it has searched as a field inside the document, right? Up, okay, so I don't, can you give me a use case wherein you would actually need that? Mm-hmm. Never been used. Never been searched. Yeah. So number of times. Okay. So you can actually have a field for that. Let's just say that number of times this book has been searched could be a field, and every time you get it into your result, you can increment that. You can store it inside the document itself if you want. So it. Yeah. Yes. Okay, so there is like a whole lot more on Elasticsearch, like aggregations, fuzzy search. So let's just say that you're making some typos, right? And yet you want the relevant results to be shown. So that's something called fuzzy search, with which you can do that. Also, you can create custom analyzers, right? So as of right now, we discussed about the default standard analyzer. Yeah. So I would encourage that all of you would go through the documentations. And think we are out of time. We can maybe take the questions after this, right? Thank you. Okay, so basically when you do this analysis process, right? So you can also specify which language you want to do it. So by default, it's considered as English, but Elasticsearch supports like certain languages as well. So if you specify that in your analyzer, then you would be able to do it. Okay, all right. That's a good question. So let's just assume that you're having an e-commerce website, right? Okay, so you'll be having all your products in your database. It could be like a MongoDB, it could be like a relationship database. On the other hand, you'll also be storing, the relevant search items inside your Elasticsearch as well, right? So you'll be, displaying all the contents with your relational database, and once you search something, it'll go through Elasticsearch, and then it can retrieve it. So in most of the use cases, you basically maintain like 2 different databases, right? One just for searching purpose, and the other one for just displaying it. There are multiple ways by which you can do it, right? So let's just say that you're in an e-commerce website and you update a certain product or something, right? So and you want that data to be updated in Elasticsearch as well. So basically, what people would do is you update your relation database first, and then you can asynchronously update your Elasticsearch database as well. So the next time you do a search or something, you'll be getting the relevant result. So there's a process of replication that could happen in the background. Okay, so I mentioned something about XPack being like one of the authentication and security plugin that you can use. So you can actually restrict users. You can also restrict indexes using that. You can give like user with role permissions as well. I'm sorry. Yes. As of right now, I did not use any sort of authentication, so you can use it without a login as well. Okay, so populating an Elasticsearch database, there are numerous ways by which you can do it. So we talked about something called Logstash, remember, during the start. So what it actually can do is, maybe it can connect to a SQL Server database, and it can do some sort of transformation, and then it can store it to Elasticsearch as well. So Logstash is also used as a data processing pipeline, right? So Yeah, it can populate all the data from your SQL Server to Elasticsearch if you want. I'm sorry? Yes, yes. Well, it depends. Maybe let's just say that you're, you're having like a whole bunch of requests coming in, right? And you find that your computers are like giving a lot of time to respond back, or maybe sometimes you feel like your system is running out of memory. So maybe during that time you can have like an additional, node, and then uh, have it, right? So you can horizontally scale it. So that is how you can easily identify how you can do it. Yeah, query response, and you feel like something is lagging as well, right? That's when you go for it. Okay, so we can take the questions after this as well, so I'll be available. So
Thank you, Vaishak, for your valuable thoughts. So I want to bring a point. We are in presenting 40th edition of Geeknight here, and yeah, as you all know, Geeknight is. Thank you. And as you all know, Geeknight is a forum for developers to present their thoughts, and we can share as a developer community. And it's free of cost, and even we welcome even more participants next time. And I think people who have joined here can also present the topics if you are interested. Please share us in your feedback. Yeah, thank you. And we can take a small break. I think we are running out of time today. So we can take a 5 to 10 minutes of break and assemble back by 7:32 or 7:30. Yeah, it's 7:27 now. So we will assemble back by 7:35. Okay, thank you.
So, good evening. I'm Kumkuma Mithun Balaji from Forge. I'm application developer who works on various segments of uh, concepts like embedded systems to the front end design. So today I'm here to present about LoRaWAN, one of the upcoming protocols that has been used for IoT, and we believe that IoT doesn't end with just data collection. It should be more useful, and in that sense, the end goal of IoT is to make Coimbatore as a smart city. So with that context set, let's jump into the today's presentation. So today we are going to see why do we need IoT and smart cities, and how LoRa and LoRaWAN works, and how does it going to supplement the other protocols that are being already exist in the IoT framework, and why LoRaWAN is the most suitable protocol for sending data when there is little needed, and what we have done using LoRaWAN, and what we intend to do in future. So the first question, why do we need IoT? Anyone? Guys, please. It's a very simple question. Okay. What's the need for communication?
Like,
Come again? Okay. 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 What else? Why do we need to do that? Okay. What is the okay? You have a live interface. You can communicate it, control it from wherever you want. What is the thing that you're saving from it?
to be
Okay. Okay.
some
So,
efficient means of to be more efficient
mhm,
in monitoring things and things like that.
yeah. To put it simple, time management. So everything can be done within a fraction of seconds, within just few clicks. All those answers were right in some sense, but what I believe, or what I suggest, or um, in my aspect, time is the most important thing that you need, and IoT is one of those technologies that help you to save time. So there are already a lot of existing protocols out there, which helps you to do those things, whatever you said, control things where you cannot physically be present, and you want to do it in few clicks. So those things are being done already. uh, can anyone give an example for using any one of these protocols where it is used? That's internet. IoT is something a bit different from that. Okay. Okay. Any other example? Mhm. Okay, that's the functionality of IoT, passing data from one thing to another without human interaction. So, w- more smart. Okay. Hmm. That's the ML part of it. That's the machine learning that comes at the end when you get all those data, and you have a sufficient amount of data where I can perform machine learning on it, and you can get some inferences from it. But before that, all a very common thing. Okay. So I don't know you guys have experienced it or not. All those highways have been automated, right? The toll gates, FASTag. That's something similar to this. It uses NFC, a near field communication, RFID. What you said exactly. So other application is a smart home. You said the automation of the home. Automation itself, it's somewhat it's one part of the smart home. When you put the ML into it, it becomes smart. So whenever you just take a day-to-day activity and you start your regular day at 7 a.m. and you don't have to set alarms for you. So if the home predicts your behavior and over the period of time, it may suggest the right time to wake you up. So that becomes a smart home appliance. And have anyone watched the CES 2020 Consumer Electronics Show? Have you seen Bali, the Samsung robot? Yeah. So that does something similar to this. It controls everything, every appliance in the house using a single robot. And so so the use cases are endless. It's up to your imagination how you implement it. And all those examples I said was with Wi-Fi in consideration, I guess. And other protocols that have been currently used are BLEs. I can see BLE nodes in ThoughtWorks everywhere, here and there lying. Yes. So used for asset tracking. And what else? Z-Wave GSM is the oldest thing, the 2G data card that you use to send data and receive. And Z-Wave is some iteration of ZigBee, Sigfox, NB-IoT, and LoRaWAN. So our today's topic will be within LoRaWAN itself. Uh, LoRaWAN, before going to LoRaWAN, you have to know something called as LoRa. It comes from the acronym long range. So the main concept that the main thing that the protocol tends to hold true is you can send data for a pretty big space, even though there are buildings for hindrance for the even there are hindrances in the pathway of the signal. You can actually send data. With Wi-Fi, it doesn't happen. Actually, you cannot get the same reception when you're sitting next to the router and when you're sitting one floor up to the router. So there is a signal loss in Wi-Fi, but in LoRa you can actually send data from one for around 10 kilometers in the in the line of sight. And if you have a higher antenna gain, you could cover more area. And LoRa is just a modulation technique similar to PSK. Anyone from embedded signals background? No one? So basically what I believe that everyone are familiar with the OSI model, the 7 layers that make up the IP thing. So in the last 3 layers, the data is actually packeted, converted into the required binary thing, and it is actually sent as a RF or sent as electronic signal or optical or light in optical fiber. What LoRa does is it converts the data that we want to send into RF using chip spread spectrum. It is a it is one of the modulation techniques that we use to modulate the RF waves before sending it out, so that it can be received by the end node. It works in sub gigahertz ISM band, so it works below the 1 gigahertz. So it actually works in 433 hertz and 868 megahertz and 915 megahertz. So it depends on the region where you live. It for India it is 866 megahertz, and it is a half duplex communication. You cannot only talk or listen to the nodes that is surrounding the existing node. And this is actually a proprietary technology. It is actually done by Semtech. They lend you the chips, which is similar to the Wi-Fi modem that you have to buy to connect to the internet, or change the signals into RF waves and then receive it in your phone. Similar to that, we need LoRa modules, something called as a gateway concentrator, and N nodes. So LoRa, in LoRa, it actually works when one node is sitting in here, and there are a number of nodes surrounding it within the vicinity region. As before I said, the line of sight is 10 kilometers, and if there are no hindrances actually, then all the nodes within the vicinity of this sending node will get the data. So that is something kind of freaky, but it has been solved in the LoRaWAN protocol. So what LoRaWAN actually does is it converts the RF packets into IP packets. We were earlier talking about the radio frequencies. It's just the modulation technique that's been done, but in LoRaWAN there is actually a software stack that sits upon the modulating hardware, and it encrypts all those data. So it is AES 128-bit encrypted and has 3 different configurations to run the node: class A, class B, and class C. Class A is the most power efficient node, power efficient way of running, and class C is used when you want to get to send and receive data immediately, like a full duplex but with some latencies. And in LoRaWAN, LoRa acts as the physical layer. Here you can see the N nodes. N nodes are nothing but the sensors that you connect to the LoRa nodes, and this uh, N node will convert the data that it has collected into a RF frequency packet, and there will be gateways. Gateways something similar to your Wi-Fi routers. Uh, to say it in a similar analogy, the end nodes can be your mobile phones, and the router gateways can be the Wi-Fi routers. So the phones get connected to the Wi-Fi, and Wi-Fi helps you to connect to the internet. Same way here the end nodes and gateways communicate via RF frequency, and the gateway helps to communicate, convert it to the IP packet, and we can actually use it everywhere, wherever we want actually. Yeah. 10 kilometers. It depends on the node you buy. There are different configurations that are available, but for a given node, by default it's 10 kilometers. If you are in a city region, it reduces way less, like 2 to 5 kilometers. Yeah. Yeah. Yeah, it can switch between receiving and sending. uh, in class A, as I said, once it sends the data to the gateway, it will wait for some time before receiving the data. There will be 2 such intervals, and once the first interval is done, you'll have a small time to send the data, and if you miss that receiving interval also, you can send the data in the second interval. So that's how it has been created. But if you use the class C, you can send and receive data simultaneously. Not simultaneously. Once the data is being transmitted, you can send data from your laptop to the node itself once you receive the data. Yeah. Mm-hmm. To be fair, there is no security issues as of right now. Even though you can receive the data with your gateway, you cannot actually decrypt it. It is encrypted using 3 unique keys, and it is only accessible to you. And it's 128. It takes a long time before that the data itself will be expired, I guess. Yeah. Mm-hmm. 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 You cannot actually send image files or video files through this. You can send text. You can actually communicate using the LoRa itself, but it will be very a low level communication actually. In LoRaWAN, what I failed to mention is you need a backhaul. Backhaul is something that helps you to transfer the IP packets to the internet. So till here everything is RF, and the gateway receives the RF packets and converts it into an IP packet. But to actually transmit the IP packet, you need some way of transmission, some mode of transmission, and we use existing technologies like 3G, Ethernet, or Wi-Fi. So it's kind of vague, but uh, where it makes sense is when you have a large number of devices, like you have 100 nodes, 100 sensors, and you have only one Wi-Fi router. You cannot actually send and receive data at the same time with a low latency in a Wi-Fi, but here it's actually possible. Mm-hmm. Yeah. No, it's actually power efficient. You cannot run. The obvious fact we miss is all the Wi-Fi routers are powered into a socket. This doesn't need that. The gateway alone will be sitting at near a socket, but the nodes they can be run with a lipo cell or a AA battery for over 6 months of time. You cannot get that with the Wi-Fi module. Yeah, it's more like a broker in between. You can. Yeah. Yeah, I get the point. You uh sense in it. Yeah. So any doubt? It's 50 kbps. LoRa Alliance. Yeah, we have something. So this is actually a LoRa module, the same form factor. Yeah. Oh, yes. Yeah. This is, yeah. That's the actual form factor of it. And on there you see the metal cover, right? That's the actual chip that's been given by Semtech. That's brought from Semtech, and that does all the RF modulation in it. So it has an onboard microcontroller to it. So the microcontroller communicates with the RF module through SPI protocol, SPI serial peripheral interface protocol, and yeah, this is compatible with the Arduino IDE. You can program it using the Arduino IDE itself. Yeah, this can actually act up alone. There is a few other versions of this that can be mounted on a Arduino Uno board, and then can be used to generate the LoRa packets. So yeah. I left the console there. So this is one another module, and this module has everything built into a single chip. So the form factor is very less when it's compared to uh, the L32U4. And please pass this around. It cost around 2,500. This is a development board. Yeah. Yeah, we have IDs and code burners to it. So the chip, that's all What? Yeah. So, you have STM32 burner, STM32 chips. So they have given a program uploaders, and there is this tool called Steamink. So you use this to upload code to that. Some boards are totally open sourced, so it is accessible to you, and some boards are not open source. The board that I given to you, that's not open source actually. Mm. Yeah, so you can use the GPU pins on that to receive data from the sensors or actuate any end, end devices. It is it can be done programmatically, and the next tool that I'm going to show will help you accomplish that. It doesn't really need a MAC address. But it's all always changeable. They can identify the node with the device ID, as said. So so this number is used to so the device UI is used to identify the end nodes uniquely. That that's the LoRaWAN. It's a protocol actually. It's the protocol. Gateways. Yeah. Yeah. Application servers. That's IP.
Sorry, what's the question?
Yeah. There are private LoRa and LoRa servers. So if you use those tags, the data is actually not available to anyone outside. Even though right now it is, we are using an open gateway, the data is not accessible to anyone except the admin.
Yeah. So actually there are like on top of what Kum said, right? So there are two levels. One is like each node gets its own you know, security, right? Its own private keys and security with which whatever the data that a node sends, only that particular application can receive the data, right? And even the other node in the same with the same application cannot see the data. On top of that, the application is like a logical grouping in one network. One network can have multiple applications. So, and each application, that's the application key that we are seeing there, right? Don't show the key. So with that application key, that provides the security between two different applications. So data of one application cannot be seen by other application at all, even though it is going to be connected. All applications are sending and receiving data through the same gateway and same network. So since LoRa and LoRaWAN is like a very wide area, like it spans across multiple kilometers, right? As somebody was asking, how do we avoid situation of even at home, like in apartments, when there are like two people close by with open SSIDs, we connect that. How do you avoid that in LoRaWAN? Essentially it is with application keys and device address. So that way, one network which is established even across the city-wide can be shared between multiple applications without worrying about what happens to my data, whether others will be able to see my data, etc. It does, yeah. So coming to that, since from gateway to backhaul it's just IP stack, you don't have to necessarily be connected to internet, right? If your application is going to sit next to the gateway connected over Ethernet cable, that's perfectly fine too. Except that your data is not going to be available in the internet, and if your application is okay with that, it's perfectly fine. Not necessarily, your app traffic has to go through the internet.
It is the software that does all the encryptions. As said, it is AES 128-bit algorithm that has been used to sign the data, and these keys right here, you see, right? These keys are used to sign the data, and once it gets back to the application server, the data is decrypted using these three keys. Yeah.
Yeah, it happens in the microcontroller, right? And your controller has to be powerful enough to do the crypto. Otherwise, I mean, these days almost all can do it. Cost of controllers are going down, but yeah, it essentially happens in the controller. But of course, you can use HSM modules and TPMs to secure the keys in the device, so that even the keys cannot be stolen or tampered from the device. But anyway, that is irrelevant of whether we use it for LoRaWAN or anything else.
Lots of applications are there. Something we itself developed are these things. So in the first thing is we have installed the N nodes, the LoRa nodes with the thermistor in the furnace lanes. It is actually it is used in a foundry, the place we melt stuff, right? So there it is used to monitor the temperature levels of each furnace, and the data is actually pinged back to the server, and it is used to maintain the logs of it. So the other thing we built is using the same LoRa nodes, we monitor the ambient temperature, pressure, and humidity. In this case, we have installed this in KMCH hospitals, and we tested it out for a period of time. And the other thing is, it has been used in a startup right now in Forge. to avoid human-animal conflicts in the forest regions. We did a test run over there. So what right now there is this thing called NABH accreditation, and every hospital has to get it. So for a hospital to get the NABH accreditation, they have to have logs of their whole hospital rooms, whether the temperature is maintained at a right point, or and pressure is right for the patients. So these critical things were measured, logged, and sent back, and it can be monitored or seen lively in a dashboard also.
One more case is in an IT campus across, there are multiple tenants, like, companies like this and others. So, and everybody consumes electricity, right? So one of the solution that has been deployed is where this energy consumption of each tenants are monitored remotely, wirelessly at 10 minutes, every 10 minutes, with which you can give daily reports to the tenants. You can alert, with all the data that you're collecting, you can do learning, and then alert if there is unusual consumption, or if there's a consumption on a weekend when it is not expected, etc., etc. I think Fumi wanna show. So yeah, of course, with when there is a line of sight, there has been experiments where people have pushed it to 850 kilometers line of sight, but that is not practical, right? Wherever we place the gateway, and the end nodes are going to be not in a line of sight in a practical situation. So in a typical urban situation, you can expect anywhere between 5 kilometers. In cities like dense cities, it is going to be even lower, but we'll see how it is doing even in Coimbatore network. We're going to show that. But in rural areas, when there are not a lot of disturbances, it can go like 20, 30, 40, even longer. 70 kilometer is my personal
Test.
Yeah, record. It's the radius. Yeah, it's the radius. Yeah.
So theoretically, it can be 800 nodes at a single point of time. And if you want to communicate more nodes, practically you have to change the duty cycle, the amount of time the node is on in a particular bandwidth. If you can change that, you can actually increase the number of devices that can communicate to the gateway.
So yeah, if the duty cycle, when every node is going to send a data point every 1 hour or so, and again, there are a lot more other factors, something called spreading factor and other come in.
Adaptive data
Yeah,
rates. Yeah.
and let's not go into the details. It's going to be too much for the first day. But yeah, you can have like 10,000 of nodes, tens of thousands of nodes in the same network. So one of the reasons why it is a typical pattern is you don't have one gateway in a network. You have multiple gateways in a network, and the data packet that a node is sending can be picked up by any of the gateways, and sometimes it will be picked up by more than one gateways as well, since the range is like very high, right? Say when a node is in a moving situation, for example, if you want to do vehicle tracking with this, and in a large city like Coimbatore or any other cities, what you have to do is like establish multiple gateways in different strategic locations, and when the vehicle moves across, the data is going to be collected by at least one of the gateway, whichever is reachable, or sometimes more than one, two, even more. So that's why typically in a standard LoRaWAN installation, there is a server which aggregates the data from these different gateways, it does the deduping as well when it is received by multiple gateways, and does all these things. Yeah, but again, it depends on your use case, right? If your use case is going to be handled with only one gateway, and you don't need to dedupe in this kind of scenarios, then you can always have the data collection and processing closer to the gateway as well. That's the distance we're talking, right? Yeah, that's again the radius. Like if you're having, so again, you can consider these gateways are something like cell phone towers that we have got, right? Mobile phones anywhere in a radius of like if it is like cell phone towers these days, it will be like 2 to 3 kilometers radius that we are talking there. They will be able to use the tower. These LoRa gateways are very similar to that, except that it's going to be cheaper and more suitable for sensor network. And once you establish the network, probably I'm jumping too much into Kum's content. Once you establish the network, you don't have to pay anybody. It's your network. In case of cell phone towers, you have to pay every month to your cell phone providers. But here, once you establish the network, it's your network. You can open it for others. It's yeah.
That's the longest, I guess.
That's me from top step. So basically, this is a map that shows like a coverage of our city, like the place where we are running this. You can see. Yeah, so we have one gateway there that is okay. That's okay. So that's the one that is running in the other campus that I was saying. That has been deployed in a like above a 5-story building, or on top of like a 30-meter, yeah, around 20-meter tower. So that can reach all the way to Avinasi on one side, Anakati on the other side, and top slip is the longest streak that we are seeing there. So of course, top slip, it is like an elevated location. That's why it was able to make a longer distance. But yeah, the longest streak that you are seeing there is the top slip. And again, practically, we can safely say that it is 5 kilometers is a safe distance that you can say or assume if you are building practical applications on top of it.
So what we had actually done is, as Silva said, we have deployed gateways. We, in the sense, the TTN community, Coimbatore community, has deployed gateways all around Coimbatore. As of now, it hasn't actually covered the whole Coimbatore city. And what we intend to do is to cover the whole Coimbatore city and open the bandwidth for everyone for communicating. Not text messages, but obviously the sensor data, and you can automate your home using this.
Yeah. Again, I don't know whether everybody got the Things Network model, right? Idea of Things Network is, people like Forge, ThoughtWorks, or Cloudflare, anybody can come together, establish our own gateways, and make it available for each other. And not only each other, make it available for the entire city or the community. Because, the range is very cheap. As long as you have you can, you're okay to offload some of your bandwidth, internet bandwidth, to relay these packets back to the cloud. You open it for many number of people and many number of use cases. So that's all this, that's what is about the TTN. So it's a global open LoRaWAN community setup network, which started in Europe, and it has been going crazy in the last 3-4 years. And we also have a community in Coimbatore, and that's the community that Kum was talking about.
Using the LoRa, you can create a mesh network where each node can ping the other node. It's not LoRaWAN, it's just LoRa.
Yeah. In LoRaWAN, you don't need a mesh, right? Again, because of the range, right? That is one reason you get longer range without mesh. And other one is for battery life that we are talking, right? There are projections that with the AA battery, if you are monitoring temperature every 4 hours, it can run for 10 years. Or other, we are talking about use cases, right? One of the classical use cases like parking sensors. There are sensors that are submerged on the floor on every parking spot, which can detect whether the car is parked or not and send the data which can be used for managing the parking space. So those kind of sensors are operated on battery, and it can last for like years, right? So how it is possible to do that is like with the simple trick of deep sleep. Like whenever it is not sending the data, the node goes to deep sleep. And when we have to do mesh, nodes cannot go to deep sleep or sleep, right? They have to be always on, radio has to be active, that means more power consumption. We don't gain much. Whereas with sleep, with LoRa, anyway we get the distance, so there is no need for mesh in the case of LoRaWAN. Or it does not go align with the goals of LoRaWAN. Yeah, of course.
It is open for all of us.
We don't use LoRaWAN for that communication. So yeah, so it's you can go to thingsnetwork.org/c/Coimbatore, like community/Coimbatore. You can sign up yourself. There is a TTN Coimbatore Twitter handle, which is not super active, but yeah, and events are posted there as well. And also there is an inactive IoT meetup group as well. And yeah, we do communicate through that as well. I mean, one of the reasons of doing this is like if there is enough interest, we can rekindle and restart the activities, core activities, so that we can do more things.
It's mostly the gateways actually. The gateways themselves are the main contributions, and if we have enough gateways, actually everyone could have their own application server and run their own apps on that. So to do a number of applications like what we had discussed earlier, the main contribution is with the hardware and not the software.
Yeah, of course. There are multiple things that you can do, right? Obvious thing is like how establish gateway, open it for the community, let others use it, as well as you enjoy the community's network. But a true community, is where you help each other as individuals, right? Help somebody who is trying to get into LoRaWAN, like this, like Kumis establishing, like doing a session. You help people if they're facing problems, etc. Of course, all those things also open.
Thanks. Yeah. Any doubts? Yeah. Mhm. 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 In India, the range is actually different for each region. In India, it is 868, 866 actually. It 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 won't be the same. That's the standard that they had set.
So yeah, but end of the day, in RF, there can be collision and interference, and it is bound to happen. Yeah, as Kumi was saying, like there are different bands for different countries based on what the country has identified as a open band that they can make it available, right? So yeah, of course, the key thing is like in LoRaWAN, the spectrum, the band that has been chosen is such a way that it is license free. Like 865 is the band that is chosen, and it is license free. And there are like different channels that are established as a protocol in LoRaWAN, which is defined. There are like 8 channels that are identified for India, typically it is like 8 or 16, or I think only US has like 64 channels, but mostly it's 8 or 16. And in these 8 channels, when two nodes are communicating exactly at the same time, there is going to be interference. But that's where, with the different spreading factor, the LoRa as a medium, as a protocol, medium protocol, right? It is resilient to this interference to an extent. It follows something called chirp spectrum. Where it occupies considerable amount of bandwidth for even less bytes of data. That's how it is able to be resilient to the noise, as well as that's the same reason how it is able to reach the distance as well. So the lot of magic lies in the spectrum, the chirp spectrum that LoRa uses as a way to modulate the signals. Yeah, and of course, like any other RF, you can jam any network. I mean, that's not going to be impossible.
Thank you. Good night. Hope everyone joins the community and start working, start contributing, help each other out. And Silva here is the guru for all with regards to that. Any doubts, anything can be clarified at any moment of time. Thank you.